Reverse percentages, also sometimes known as backwards percentages. The goal here is that we're going to try and find what the original amount was before a percentage change. What we've looked at so far is given the original amount, and we apply a percentage change and work out what the new amount was. But imagine I told you what the new amount was, could we work out what the original was? So the wee example here is I have a tree. Now I know the tree is grown by 25%, so it's 25% taller, and the new height of the tree, or the height of the new height of the tree, is 10 metres. Can we work out what the original height was before this percentage increase? Now, based on what we've done before in percentages, we're always going to consider the original height of the tree as being 100%. So that's a common thing you'll see throughout this percentages topic. I'm going to label this original tree before the percentage change as being 100%. So I wonder if you can think to yourself, what would the percentage of the new tree be? What percentage would that represent of the original? Well, in this case, we've added 25% on to this original 100%. So my new tree is 125% of what I started with. Okay, so what do I know? Well, I know that the 125% was equal to 10 metres. I'll just write M for short. So the 125% was equal to 10 metres. Then what I'm trying to do is work back the way to try and work out what 100% was. Now, don't fall into the trap in saying that you can subtract 25% from both sides. Remember, 25% of this bigger tree is different than 25% of the smaller tree. So we need a slightly different way of doing this. Now, a nice way is to go down to 1% first. So if I know 125% is 10, what I can do, based on what we did before, we can divide both sides of this ratio, or this equation, by 125. And that will tell me what 1% represents. And for these questions, in general, you'll be given a calculator to do this, so feel free to sit with your calculator and go through this. So I know that when I divide 125 by 125, that gets me down to that 1% that I'm looking for. And then I need to do 10 divided by 125, which gives me 0.08. So I know 1% represents 0.08 metres. But from here, 1% is a great percentage because I can work out any other percentage by just multiplying. So from 1% to get back to my 100%, I'm going to multiply by 100. So multiply both sides here by 100. Therefore, 1 becomes 100%, which was the original height of the tree. And 0.08, we don't even need a calculator for this one. When I times 0.08 by 100, I just get 8 metres. Therefore, the original height of the tree was 100. Therefore, the original height of the tree was 8 metres. We'll look at a couple of examples, going through using the same procedure, the same approach to these two questions in context. So example 1, Andy gets a 3% pay rise. After the rise, he is earning £40,685 per year. What was his earning before his pay rise? So, again, we're going to consider his initial pay as being 100%. So this new pay we're told he has, this is after his 3% pay rise. So think to yourself, what percentage does that 40,685 represent? if he's had a 3% pay rise? Well, let's see if you guessed it or worked it out. If we had our original amount, his original wage, and we added a 3% increase onto that, then his new wage after this percentage increase would be 103%. So what we can say is that new wage he's got represents 103% of his original wage. So 103% is equal to 40,685. Now, from there, again, I'm going to go down to 1%. Let's see what 1% represents in the first place. The way we do this is we take this percentage quantity and we divide by that number. So I'm going to divide by 103. But if I do that to one side of my equation, I need to do the same to the other. So I divide that by 103. So 1% is equal to, so let's see what 1% represents. And the way we do that is we take our 40,685 and we divide it by 103, which gives us 395. Okay, but remember what we're trying to work out. We're trying to work out what the original amount was, so what the 100% was before we added that 3% on. So we need to go back up to 100%. The way we do this is we take our 1% and multiply it by 100. And if I do that to one side of my equation, I need to do the same to the other side. So let's see what 100% represents. So his original amount, 100%. Well, again, we don't really need to use a calculator for this one. We just need to multiply this by 100. So we end up with 39,500. Now, the great thing about these questions is you can actually check your work. So I could work out what 103% is if I start with 39,500. I could work out a 3% increase, and I should end up at 40,685. So it's a nice wee check you can do. So for example 2, a car is valued at £3,780. This is 16% less than last year's value. So we've got the new year's value, and we know this was a 16% decrease from the original last year's value. And we want to work out what the value was before that decrease. So again, it's definitely a backwards percentage because we're working out the quantity before this 16% decrease. Okay, so let's have a wee look. We started off the previous year with our original amount. So remember, original amount will always be our 100%. But then what happened? So we then fell by 16%. So what we need to do is take our original amount and we need to remove 16% and see what percentage we're left with. Okay, so we should end up there with 84%. So the next year is worth 84% of the original value. And we can see that after that 16% decrease, so the 84% was equal to that £3,780. So there we go, we can set up that wee equation here. The 84% is equal to 3,780. And now the process is just the same as before, because what we're trying to do is get back to what the 100% was. We want to work out what the original amount was. So the way we do that is we take our percentage amount and we change it into 1%. And the way we do that, to get 84 down to 1%, we divide by 84. But again, if I do that to one side, I need to do the same to the other side, so divide that by 84. So I'm left with 1%. And on the calculator, on the right hand side, you can just put this into your calculator. So 3,780 divided by 84 leaves us with 45. So a nice number there. Okay, that's our 1%. again trying to work out this 100%, so we now need to multiply it back up by 100 to get our original 100%. Therefore, we can say that 100% is equal to 4,500. Okay, so before that 16% decrease, we had 4,500. The car was valued at 4,500. And again, you can check this by working out and have a wee go at the two questions. See how you got on, then check with my Okay, so two more examples on backwards percentages. What I recommend you do is pause the video right now and have a wee go at the questions, and then resume it and see if you agree with my solution. So example 3. Right, a coffee shop has increased the prices of Americano by 2.5%. So after the 2.5% increase, the new amount is 246. So let's see if we can work out what the original price was. Okay, so we had the original amount before the increase. We then increased it by 2.5%, and that left us with 102.5%. So this new amount represents 102.5% of the original quantity. So let's set up our equation. So the 102.5% is equal to £2.46. Again, same as before, we need to now convert this to 1%. So the way to do that, well, this is a bit of a trickier number, but the process is the same. We just divide by whatever this number is. So 102.5, and divide this by 102.5. From there, we end up with 1%. And in your calculator, all you need to do is 2.46 divided by 102.5, which leaves us with 0.024. Now, I'm going to keep this as 3 decimal places right now, just so that when I re-multiply it back up, I haven't missed any digits here from incorrect rounding. So I'll keep it like that, although it doesn't make much sense at the moment as money. We'll then multiply by 100. And let's see what we're left with. So 100% is equal to, when I multiply this by 100, I get £2.40. Now be careful that I do end up with 2.4 here, but because we're dealing in money, we always need to have 2 decimal places if we have any decimal places at all. So we need to put an extra 0 at the end there. So £2.40. Okay, example 4. A plane's altitude drops by 36% to 1,560 metres. What was this altitude before the drop? So again, backwards percentages, because we want to work out the value before the percentage change. Now, let's just make sure we understand what's happened here. So we had our original amount. So the original altitude of the plane, it then dropped by 36%. So I'm going to subtract 36 because it's going down. So that leaves me with 64%. Now, its altitude is now 1,560 metres, therefore that 64% represents that 1,560 metres. And from here, once you get this equation set up, the rest is just the same. So we're just going to divide by whatever this number is. So divide by 64, and then we'll re-multiply it for 100 once we get that. So therefore we're left with 1% is equal to 1560 divided by 64, which is 24.375. Again, note that I'm not rounding at the moment. I'm just putting all the decimal places in, and then I'll deal with anything I need to do at the end. So we then multiply by 100, multiply by 100, and we're left with 100%. So the original amount, 100%, is equal to 24 37.5. So the original altitude of the plane was 2,437.5 metres. And again, we can double check that in your calculator if you need to. Double check what a 36% decrease would look like if we started at 2,437.5. And you'll see we'll end up at 2,400, and you'll see we'll end up at 1,560. Okay, so I encourage you to go back and try those examples again without